Hello guys, today we're gonna create a 3D raycasting game in Scratch. Here starts my video. So this is actually when we're gonna start. So create one project and delete this old Scratch project and go boom boom with it. And now we got this little canvas. Zoom into mostly these 4 pixels we're gonna be focusing on. Now we're gonna draw a basic square that is 8 by 8. So, and I usually just do that and make it 8 by 8. There we go. It says 8 by 8. That's good. Now, over there, and then click that, delete it, and then just put that right over there. You get like a triangle thing. I know it's looking kind of weird, but yeah. So there we go. Now we create another costume, which will be our hitbox. And our hitbox is going to be kind of like way smaller. So it's going to be actually 4 by 4 this time. And then, yeah, and then we'll put it in the middle. There we go. Easy. Now, next step is to actually make a new sprite, which is actually going to be the entire map itself. So, and maps are kind of annoying to make, so what I usually do is just make a bunch of squares. Like, literally make a bunch of squares. You could add 1 or 2 circles, but don't add too many. You'll see later on the video when it actually gets to cool 3D parts. So, yeah, and you might be asking, when the 3D gonna happen? Well, you see, Scratch is 2D, so we can only make 2D sprites. So we're just gonna make the 2D map and the 2D player. And we're as well going to make a renderer. And the renderer is going to be the object that will draw all and everything about it, including the scene that is 3D. And it kind of looks weird to be just a big old circle that's going to be making everything. But trust me, that's what's meant to happen, because drawing is probably the most, and you probably saw so many other projects being so complex that you can't even memorize. But this one you could actually memorize, because I'm the one that actually memorized this before. And if you're saying, is this hard or easy? It depends on how you are like, because for some it's hard, for some it's easy. And for me, it's kind of medium, because I usually make mistakes. There's a very low chance that I didn't make a mistake, so look out for mistakes, because I am a mistake maker. I have like 1 over there, why not? And 1 over there, why not? That's a lot of stuff. Whatever. So, we'll duplicate this sprite, and now we'll delete this one. Yeah, and we only have this box, and this is just gonna make everything, you know, so, yeah. And let's actually do something. Seriously, like, actually. Let's go to the code and go into Sprite 3 and make some My Blocks, because every single 3D game can't work without a My Block. So, delete one and click Ray and run without screen refresh. There we go. Make raycast and run without screen refresh for that as well. Down there, and that goes there. And now, next in Sprite 1, we need to as well make another one, because for collision. So, move, input this time, and we need steps. When without screen refresh. And there was also, this looks pretty good, and there's nothing really going so far, so far so good. Now, let's go to actually coding. So this time we gotta go to Sprite 2, and as it's kind of annoying to see a map that's just not even in the center, so you'll go one green flag clicked, go to 0, so the map goes to in the middle. So yeah, there we go. That's in the map in the middle. You see. Now, the thing is, we need movement for our character. 2D movement is going to be good so far, only for now, because it's 2D movement. So, one green flag clicked, forever, if, and an if. Then, make sure if it's, sensing, and there we go. So, if key, up arrow pressed, down arrow pressed, key right arrow pressed, and key left arrow pressed. So far it's pretty easy. And then do move, but you will see a problem coming up real soon. There's gonna be one problem that you might want to care about. So look out for that, and there's gonna be a problem. So a normal person will be like, yeah, la 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 la, I'm doing this, yay, I'm gonna put this to 6, and I'm gonna put this to why not another 6. Whoo, yay, I'm a coder, I made movement, woohoo. But the thing that you don't want to see in the game, it's like, yeah, it looks pretty damn good, but I could go, walls. I could go through walls. We didn't tell the game about any wall collisions, so I'm going through walls, which ain't what you wanted. And let's change that. This is why, and it's impossible in Scratch because these move blocks can't just detect it like that. You can't just go. And if that is actually possible, it won't go fast. This is why we made our own block move. This block will have its own code that will have collision forces in it, because Scratch doesn't have collision forces built into it or any physics or 3D rendering. So we gotta use this block that we just made. So remove these old move ones and put these new ones. And we'll put negative 2.5 as it just did, and and there we go, and 2.5. There we go. Now we got these two things, but they still won't do anything. They can't go forward or backward. They can only go left and right, because that's what we really have. Because the game doesn't know what this is. It's not like the game just, looks at the block and just guesses what it does. It can't do that. Scratch can't do that. So the way to do it is this. This tells Scratch what these move blocks actually do. And we want to as well put collision forces. So this is what we need. We need it to change into an hitbox, which is custom 2. And then we needed to custom 2 is the little hitbox we made there. So yeah, custom 2. And then set rotation style to don't rotate, because that's how hitboxes really work. They don't rotate. And now it has to actually move like it moved. Like that's what they do. Now we wanted to make sure if it is touching sprite 2, it has to make sure that it has to get back out of that wall. So it has to move by a minus amount. So 0 minus steps. So it goes negatively out there. And now we just duplicate this part and then put it down here. And there we go. And now we change this costume to costume 1. Don't rotate, to all around. And bam. It moves. It actually does move now. But look at this. Collision forces. So yeah, you can see it with your own eyes. It's actually working, and I'm not scamming you. So it's collision forces in the game, actually. So yeah, now we want to move on to like 2D. This is what we'll be doing in the 2D game, but this is 2D, so we want to turn it into 3D. Now we're gonna do stuff that are not necessary in the 2D game, but as we make in 3D game, this is gonna be necessary. Because we'll be doing it in raycaster 1, so we'll go into the code of this. We need to make a wall detection script. And script that can detect a wall. So let's do it. Way to do that is to go into the vents, and then, for now, we're just gonna make a small little shotgun. Just gonna make a little, pistol shotgun, and just make a small little shotgun, just a simple shotgun script. It has to actually, so, point in direction, what is that direction? It's gonna be the actual, as well, I missed one thing, just put here, don't rotate, as well, so don't rotate, just make sure you put that, don't rotate, yeah, don't rotate. It will prevent glitches in the 3D game. So when space is clicked, it has to now set the so yeah, and now we gotta make sure it is in the way that that the player is in. So sprite 1, so sprite 1 and direction, and now make sure it go now. So it goes sprite 1, and now this is where it actually starts moving. So repeat until. So it's a repeat until script, and now it has to repeat until touching sprite 2, which is the map. So it's going to be all wall detection. Now I got to move 4, 4, 4, 4 like that. Now we will duplicate this, and then take away this touching sprite 2, and then put a knot in there. And then change the move steps from 4 to -1. And there we go. You can see it's -1 now. And now if we start it, and then click space, it shoots out a little red square thing. And the move out script, it's always perfectly out. So as you can see, it's just perfectly out there. Just out. And I use a little code to do that. Yeah, just out, yeah. Super cool, and yeah, and it's like a shotgun script that'll detect the walls. Now, we don't want to keep on clicking space, you know, because that's not how things work. But we can use this ray, because we don't want it to just take time, because it takes time to move and go there. We don't want it to take time and to get there. So we don't want it to take time to get there. So how do we do that then? Good question. You take this go to sprite 1 and put it all the way there, because this is one without screen refresh. So this block has power to do this instantaneously. So start it. Now we click space. It instantly finds what's in front of you, which is super cool. Now we don't want to keep on clicking space. So the way to fix that, I'll say, is yeah. What do we do? Good question. To actually stop it from doing so yeah. How to do that? Remove this when space clicked, and then put when I receive the message of Ray. Why not? Then go here and broadcast Ray. Put that there. Now, if we start it, we ain't clicking anything, and it's just, you know, doing its thing without, you know, yeah. But now, to make its wall detection more easier, we wanted to make more like and detection more easy, you know. So yeah, there are gonna be some glitches gonna come later, so yeah. So this is how you will fix this thing, and yeah. So let's make a laser now. And the way to make a laser is to make a laser. You say, are we gonna use clones? No, because clones are not gonna work. Plus they have a 300 clone limit, which is kind of not cool. And yeah, so we go to the bottom left. We have this little add extensions thing, and then we click it, and we have this blocks, just a bunch of stuff here, and you click pen, draw with your sprites, and you can see where this is going now. We have to click erase all now, because we got this whole new blocks, and then we do set pen size to 4, and then we gotta do the set pen color to whatever you wanted. I am a big ol' 53 Jedi blue guy. So now nothing's gonna happen, as you can see. Boop. Because this script does everything. This is just setting stuff. It didn't actually draw it. So we gotta do pen down so it starts drawing. Then it stops drawing. Just right over here. And then bam. We got a laser beam, baby. Woohoo, yeah. Whoa, yeah, baby. I'm loving these lasers. Now, see, this is a wall detector, but we are trying to kind of make light, you know, and light is not like this. light is more like wall detection, and we want light to be a little different in our world. See, now, so this is the problem. This is just one ray. We want to fire out rays in multiple ways so we can detect walls all over the place and then find out what the player should be able to see. So let's do that. But this is where we get about to be 3D. This is where this raycast block comes in. And then we got to go repeat. But by how much? That's a good question to say. It's by field of view. But how do we know that? We got to delete this thing and make a new variable saying field of view. And we're going to make some other variables, which we don't need right now, but we're going to use later, like distance. So you can know the distance, and as well height. That will be pretty damn useful, knowing the height of the walls, and as well, most importantly, x, knowing how much sideways the wall should be. So you're going to delete all these, and bam, there we go. We got the FOV one. We're going to make sure it's like that in the slider mode, and then we're going to right click it, change the slider range, turn 50, and the other one into 120. Okay, let's go to sprite 3 again, and start doing some more code. So now, field of view, FOV. Now, we want to take this ray block and put it here, actually. And then, we're going to move the other way. And I usually do this way, mate. And just do 1 degrees is what I do. Bam. So yeah, nothing happens. You know why? Because raycast needs a raise cap skip, so we didn't really even run it. So there we go. Now we're gonna run it, and what the hell? And yeah, by the way, you gotta change this actually. So there we go. Now it should be working just like that. And wow, look at this. It's looking so cool looking. Woohoo! So yeah, as you can see, it's going as planned, like light. Now, but there's one problem. Move this to higher mode, then you see the problem. The player's looking that way, but the light is shining all over there because the computer is only changing it in this way. As it said over here, only turn that way in 1 degrees. So it'll only turn that way. So how do we fix it? We turn it the other way, the half. So then, this is where we get a tiny bit more math. So now we turn the other way, the opposite way, and then we divide it by 2. What by 2? The FOV value. And just like that, my friend, we have a little bit more fixed. Now you can see everything is now fixed and centered. And oh my gosh, this is so fun to play with. It's just like light, you know. This is just light, and I like this thing about light. It's easy and fun to play with and easy to make. It takes a lot of time, but if you focus on it a little bit more, it doesn't take as much time. Oh my gosh, this is the walls are kind of annoying to say the least. So there we go. Bam. We have this little light thing here. Now, you might be asking, Bo, get something that is 3D. And fine then, because now, this is the time when we get most of our stuff and most of the variables to make 3-dimensional. Isn't that fun? So, now, we're going 3D. So, let's make some 3D now. Now this is actually going to get 3D. We get 3D view and that stuff now. Let's do this. First, on top of this, we put that. Saying, set the X to negative 240. This is the value of half the screen. Now next, we need to change the X by an amount because of the FOV. Now, next step, now doing this, we need to change the X by a division operator because we're using FOV variables. by 480 480. What is 480? The entire length of the screen. It's the entire length of the screen, which is the entire screen's length. The entire screen's x. Now we need to divide it by 5. And now that's literally everything that's we're gonna add over here. But that's not it. We gotta put more 3D into here. This is where most of the code will come. So next step is to remove these pen down and pen up variables, because we don't want to start drawing 2D lines like this. We want to do 3D now. So we need to get some information like the distance and the height. So the distance is simply the distance from the player, which is sprite 1. And if you want to know the height, we use the distance to know the height of the walls. And now we gotta set the height to something. And we gotta divide it. And on this side is gonna be by distance. And we gotta divide it by distance. But this side, we gotta divide by distance. What is this side? This side is like the average height of the walls. And for now, you can add 3,000. I know it's a big boy number, but that's how it works in this world. So that's the average size of the walls, and this is gonna tell it what the size of the walls. If you get near, more bigger. Get far, more smaller. Now we know all information about the x, the distance, and the height. Now we have to finally make it, and now we gotta draw it actually. So we gotta now go to a specific position, which is X. And it as well has to go to Y. But X is like the sideways in real life, but Y is up in 2D, but Y is actually height this time. So Y actually equals into the height, and X is just simply the X. Now we needed to do pen down. Now we gotta start doing stuff, and that is in set Y. And let's do not division. This time we're doing minus. And we gotta do in 0 minus the specific amount of height. Now, and then we have to pen up. Now, I hope this worked, because I usually do mistakes on this time. Please work, please work, please work. Oh, it actually worked. Is it working? Oh my gosh, look, it's 3D projection. But this is not it. It's kind of blurry and broken a little bit. And I kind of know some fixes into this 3D projection, because it's drawing lines. The basic thing it's doing is just drawing a bunch of lines and making the view. But they're like, bro, the map and the player is literally just on it. Is that a good thing? No, definitely not. But what if we want to make a map? We could add maps into it. You want to? Fine then. Let's make a map. So if you click space, it'll make a map. So for sprite 3, we can't just hide it, because then the wall detection will just be completely broken and probably crash scratch straight up. So we have to instead we have to make it transparent, basically. So we have to do a set ghost to an 100. And then go bam. So, and bam, that thing is gone. Doesn't really do much difference, but if you don't want to show what it does, yeah, that's one thing. Now, we want to make a map. So this and the player, so the map and the player should be shown when it's meant to be happened. So that has to go forever, and we have to do an if-else script. And the if-else script is going to work like this. So if it's when the key space is pressed, that means that the when the key space is pressed, it has to go to 100. Actually, it should not be invisible this time. So it actually sets the ghost to 0. But if it's not, it just has to be invisible. So 100. It's not being invisible. It's kind of just being transparent. And there we go. And I forgot about the player. Whatever. Let's just put that in the player just like that, and bam. Now the player's up there. Now if I click space, the map comes up. And it's kind of cool, but bro, the 3D projection is kind of broken, to say the least. So, in fact, yeah, so first thing, let's make the background, because the walls are kind of just floating. So, let's not make the walls floating. Does that look good for you? So, yeah, let's make the walls not float. And plus, for now, actually, just hide the far variable. And when you hide the far variable, it won't show up there, but it's just hidden. So, don't worry, it's still there. The value's still there. Now you go to sprite 3, and then just put and set fov to 73. That's what I usually do. And then I set the pen size to 7. Bam, the view is kind of a little broken, but this is gonna get way better, trust me. Now, first thing, the walls are floating. How to fix that? We're gonna use a background and make it like it's a floor. So use the background. Let's do this really cool effect where we fill in, and instead of doing just one big color, we will do that. Now we want to choose this one, and then we kind of want to make it more darkish here. So yeah, and then bam, we have this little knot and circle. It's a rectangle. There we go. And you got this really cool floor. Now, let's do it same for the up. So we're going to swap it over. And then go just like that. And yeah, there we go. Now, first problem fixed. The walls are not floating. But there's one thing that I don't really like. It's more like it gets more darker far, but the walls don't get darker. There is a way to do that. We can set the brightness of it. So let's do that. So sprite 1, into sprite 3 back again. Let's add a little bit more. Why not? So now, the more far is the more darker that means. So let's go to pen, which makes that draws everything. Let's do it has to set the pen brightness, and it as well kind of gets a little bit with the distance. So if you want to know the distance, we're gonna use the distance to know the color and the brightness, I mean. So this is what we do. We firstly have to take an operator, and we're gonna firstly do a minus, and then we're gonna do a division, and in the middle we're gonna put the distance. Now, with this, you gotta make sure over here is a 120. And over here must be a 1.5. And now we put this value into the brightness, and then, bam, it gets fixed. And it gets more near, and then it gets more, and there we go. It kind of mixes up with how that works, so it looks better. Now, first step, I look at an edge. So, yeah. I look right to this edge, and then See, this edge kind of flicks a little bit. The way to fix that is because the render sometimes skips over it, and then yeah, this happens. And you can't fix it completely. You just can't do this. Make it 2. There we go. Now it will still happen, but as you can see, it's super less now, and it won't miss it. But the cost is that it gets more glitchy. So yeah, and if you don't want it to be glitchy, yeah, so yeah. But there's one way to fix it a little. So there's one, and yeah. Now as you can see, next thing is, see, most 3D games forget to add this feature, which fix one problem. Look at the wall. It looks curved, but when in real life, it's actually straight. It looks curved. You know why? Because when we shoot at a ray, it hits one, but at the side, it's all far. Even though it's the same line, and it hits one place, but it's near, but on the far, it's more far. And then the game just is like, yeah, this is what happens, guys. And then the way to fix that is to use a little bit too much math, like way more math. This is how you do it. So we actually have to set the distance into a different variable, so the height will be changed, and yeah. But we're gonna still use the normal amount of distance. So we gotta use the multiplication. Then we're gonna actually use the cos, which knows the cos of what it is. So cos multiplied by the minus. Minus. There we go. Now, but to do this, we'll need another variable, which is dir. Dir. This is direction. Hide that as well. Now, to do this, go all the way over here. And then do a set dir to direction. So, we'll do that. And it sets the dir to an amount of direction. So, we'll just do that. Now, we'll go back to where we were. Here. Now, we need to, start doing stuff. Okay, we gotta do the distance multiply the cos of minusing the direction, and direction of dir, and yeah, and then put this big chunk of code in this distance, and then bam, you see it like this. But when you get close, it kind of gets a little bit like this, which kind of annoying. But there's one simple way to it'll still happen, but it will reduce it, and we can just put this move to a negative 0.5. As you can see, that's a little less, so yeah, you can't see it much, but as well makes it more glitchy. But yeah, it kind of reduces it. Now, what else do we want to add? It's really good. It's going super good and nothing bad in it. But there's one problem. In fact, there are 2 more problems that are going to come lately. First thing, look. We're easily able to know the distance by the color of the walls. But now, we need to now have, so now, there's one thing that we can't easily see the corners. The corners are a little hard to see. And the way to fix that is to make each side different color, so the intersection will be a little different. The way to do that is to make a whole different sprite. First step, we have to duplicate the map. It's kind of crazy looking, but yeah. And as well, make sure the map is centered as well. Yeah, so. Is it centered? And like, most maps have to be centered, so just make sure that this one is centered. Centered, and as well make this one centered quick. Yeah, most people forget to center it, so yeah. So this is going to be telling the color of the map. First step, duplicate this. The next, select this entire thing, or you can do Control A. Then just click on your keyboard. The other, so just click right arrow on your keyboard and go, boop. It moved a little bit. Now copy. As it's copied, you can delete it, and don't worry, it's copied. Now we'll select this entire thing, and then just move the other way. The left arrow, boop. There we go. Now we'll do paste. Boop. There we go. Fixed. Now we go to the code of this sprite 3. Now this time we have to separate this a little bit, and then put an if else into it. If it's touching sprite 4, it will have to change the color of the pen. And the color, I usually do pure red, so that's a 0. Then, otherwise I do an 53 Jedi blue. And then you can delete this set pen color now. Now if we start it, whoa, that's looking so cool. Now you can see these edges, and it is more glitchy, but it's better. Not that much more glitchy. But see these problems. Look at this. This is an tilted square. And it kind of gets confused with these tilted stuff. And the way to fix this is to go into sprite 4 and then actually change sprite 4 a little bit. So we are looking at this square, which is tilted. We have to change this square into a square like this, and then select this, delete it, select another one, and delete it. Now we have this. Now if you run it, you see that's fixed and just separated into 4. But I'm going to tell you one more thing. Just go to one of the circles. I'm finding some circle. Whoa, whoa. So the circle should be just around this corner. Aha, you see this circle? The circle as well has the same problem. Circles as well have the same problem. So, we need to change that as well. So, change both of these circles because they have the same problem. Now, boop. And then we take this and then select this. Bam. Bam. Now as well do same for this. And then select this one and bam. Select this one. Bam. There we go. Now back to the code, and it should be fixed. As you can see now, it's just separated into 4 different colors. Now, as you can see, this is a super cool 3D exploring game. It's super fun and cool, and I mostly like it. Super fun, and I hope you like this video of how you make a super cool 3D explorer game, and I hope you like it. Super fun, and yeah, bye guys. I hope you like it. So yeah, and I did a lot of work for this video. I hope you like it. Make sure you subscribe and like to this video, and yeah, have a nice day.